Okay, so I promised you in my last video that I would talk to you about a few things. I'd show you some examples of scatter plots. I would show you some positive and negative correlations. I'd talk about strength of correlation, and I'd talk about a number that represents that strength of correlation, the correlation coefficient. Now, you're not required to understand how to calculate the correlation coefficient, but I want to talk a little bit about it just so that when you get to that point in high school, you'll be able to make a connection back to this scatter plot thing in this class. First of all, I want to talk about the correlation coefficient. Coefficient kind of just means number. It's just a fancy way of saying the correlation number. Okay? And the correlation coefficient is a number that represents how strong a correlation is. That number is always between a -1 and a 1. Okay? And the closer you get to 0, like this, the weaker the correlation. The further you get towards -1 or 1, the stronger the correlation. Now, we're used to thinking of weaker as less and stronger as more, but this once again is a case of absolute value. We're talking about the distance from 0. 0 being no correlation. Okay? And the further you get from 0, the stronger the correlation is. Okay? Let's look at a few pictures of correlation. Here's an example. Perfect positive correlation is right here on the left. I'll bring it up here so you can see it. You'll notice this is perfectly linear. You can just draw a line straight through here. Okay? That's a perfect positive correlation of 1. All right? High positive correlation is when you do your scatter plot and it looks like this, and that's about a 0.8. Low positive correlation is a little more scattered, but you'll still notice that there's this circular, almost oval, not circular but oval shape to it, where the no correlation section, where there's 0 correlation, is more of the circle. Okay, there's really no sign that there's a correlation at all. All right, see those differences between high and no correlation, and these are all positive correlations. All right, and you'll notice every one of them is going up from left to right. It's going up in a positive way. All right, except for this one isn't, because it's a 0. Now, as we go into the negative correlations, you'll notice it's still got an oval like this one, but now it's going downhill. Okay, the slope is down. And as you get closer and closer to -1, they go downhill, but they're closer and closer together until you have a perfect negative correlation of -1. This is a strong correlation, even though it's negative. It's very strong. Cool? So positive correlation uphill, negative correlation downhill. Strength of correlation means you're getting closer and closer to linear on either side, okay, of your 0 line. All right? That's a little bit deceiving here, because these guys went from 1 to -1, and they should actually have gone from -1 to 1. They should flip this thing over. There we go. Looks like this. Now you can see that you have a negative correlation here going down, and it's very strong. And then it's a little weaker, a little weaker, a little weaker. This is still a really strong correlation. A little weaker, and no correlation, 0. And then your positive ones are going uphill until you get to +1. Very strong, perfect correlation, very strong correlation, somewhat weak, and a 0. Cool? All right. Let's see how that works out. Now that we've talked about correlation coefficient, I want to show you a few actual data sets that people have gathered. This next one I'm showing you came from people.vcu.edu, right there. It's a correlation between the number of drinks you have per day and your grade point average. You'll notice it's a negative correlation, meaning that the more drinks you have per day, the lower your GPA. A negative correlation means more of one thing means less of another thing. More of this means less of that, so that's negative. Okay? More of this, less of that. And you'll notice if you drink more, this is alcohol by the way, your GPA will be lower. And look at that. Pretty good negative correlation, negative 0.8, very strongly correlated. Next example. This came from online courses. .science.psu.edu. I think that's Penn State University. This is a data set that they came up with where they gathered numbers about people's quiz averages and then compared them to their final. You would think that if people score high on the quizzes throughout the year, they'll score higher on the final as well. And you can see, they don't have any numbers on this, but you can see a somewhat strong positive correlation. Probably 0.5, 0.6, okay? Pretty good correlation between quiz averages and final. This one comes from onlinestatbook.com. It's a correlation, and you'll see these all over online, but you'll notice there's a correlation between the husband's age and the wife's age of the people that they interviewed. Very strong correlation. Every once in a while, you'll see somebody out there with a little dot out here somewhere. It's called an outlier, okay? Meaning they don't really fit the norm, okay? All right, here's an illustration of national income. This was done in 1963, and it's all over the internet. But in 1963, they did a thing where they talked about national income per head, how many people per person, how much money per person they made, and then the expectancy of males, the life expectancy of males. And according to this, the higher your income, the higher your life expectancy. And I'll leave you to think about why that might be. Another one from mathisfun.com. I liked this one. This is a positive correlation once again. The higher the X value is, the higher the Y value is. This is actually time from 1993 up to 2011. Okay? And it's sea level. All right? And you'll notice that as time goes by, as time gets higher, the sea level is rising. And this is one of the data sets that's used a great deal by those who speak of global warming. Because if the ice caps are melting, then the sea level is rising. Okay? That's what they're saying is making the sea level rise. I'm not going to wreak political on that. I just wanted to show you the chart. Here's one. Very simple one. Time spent studying versus student grades. Interesting. Now you don't need me to tell you that there's a correlation there. It looks like it's about 0.8 correlation, positive correlation. The more time you spend studying, the higher your grades get. This once again is from people.vcu.edu. Here's one that I did. I was listening to the radio, and there was a radio announcer interviewing somebody about their gun laws, and I decided to go out and actually look at the stringency of gun laws versus the number of gun crimes. And here's a chart that graphs the number of gun crimes per 100,000 in each state of Utah, in each state of the United States, versus the stringency of their gun laws as ranked by Brady. And that shows that there's actually a positive correlation there, 0.068, very weak correlation, almost zero. Okay, so there's pretty much no correlation here in the chart that I created between the stringency of the gun laws and gun crimes, how many gun crimes there are. Interesting thing to look at. And I started looking at all these statistics and thought, I'm going to try to find a statistic that will show a strong correlation between instances of gun violence and something else. And I looked at several different things. In fact, my data source on both of these, www.statemaster.com, has thousands of different data sets that you can look at. And after I looked through a whole lot of data sets, it's really interesting. The data set that I saw found the strongest correlation was this one. Correlation coefficient of 0.48, stronger than general violence, stronger than violent crime, stronger than anything else. The correlation I found that was strongest was between the instance of gun violence and, I'll let you read it this way, percent of parents who read to their children every day. Very interesting. The more people are reading to their children every day, the lower gun crimes are. I'm looking through some more data sets, and maybe one of the challenges I'll send to the kids is to find a stronger correlation than that one. That'll do it for showing you some data sets and the strength of correlation.